This is a video for OCR Pure Core Mathematics, Calculus 3, Integration using Partial Fractions, 3.2, Partial Fractions with a quadratic factor in the denominator. So far, you're familiar with partial fractions with linear factors in the denominator, whether those are single or whether they're repeated. So what difference does a quadratic factor of the form ax squared plus b make? How would we split this into partial fractions? Let's look at this example. How would we tackle something like this? Well, the first factor in the denominator is easy. That's just a linear factor, so I can write it as a over x plus 1. But the second factor, I need to consider that the power on the bottom is higher than 1. So I'm going to put a numerator which is 1 power less than the denominator. So because this is x squared plus 3 on the bottom, I'm going to have a bx plus c on the top. Now, as before, we cross multiply by the common denominator, and that's going to give me this, a times x squared plus 3 here, and bx plus c times x plus 1 over here. Looking at this, I can see that a value of x equals minus 1 might serve to get rid of the second part of this for a moment. So let's have a look at x equals minus 1. I'm going to get 4 for the left-hand side, and that's going to give me 4a and nothing here. So that's going to give me that a is equal to 1. Now, what else could I use? Well, this bit here will disappear if x is equal to 0. So let's try x equals 0. I'm going to get 5 on the left-hand side. And here I'm going to get 3 lots of a plus this thing will boil down to just c. So 3a plus c equals 5, and we know that a equals 1. So this is going to give me that c equals 2. Now, how do we establish b? Well, I've no values of x left that I can zero something out with. X squared plus 3 doesn't have a real value for x to make that 0. So I'm going to have to look at coefficients. And in these cases, it's usually simplest to start with the highest power. So I'm going to look at x squared terms. I haven't got any on the left-hand side. I get a here, and I get a b from here. Everything else has a power lower than x squared. So I've got a plus b equals 0, and I know that a equals 1. So together I'm going to get that b equals minus 1. And now I can write out my partial fraction then. X plus 5 over x plus 1, x squared plus 3. That's going to give me a, which is 1 over x plus 1, plus bx plus c. Just need to be a bit careful here because the b is negative and the c is positive, so it's actually going to be 2 minus x on the top line and x squared plus 3 on the bottom. Okay, so there it is tidied up for you. There's the linear expression on top of the quadratic on the bottom. We've multiplied through by the common denominator. x equals minus 1 because of this bracket. That gives me a equals 1. X equals 0. Well, I get something involving a, but that works out to be 3 because I know what a is now. So I get c equals 2. And then finally, by looking at the x squareds, I get that b is equal to minus 1. And so there's my final result. So the summary template, if you're looking at something like this, and this covers all that we've seen so far, if you've got a linear factor, then you end up with a single fraction for that linear factor. If you've got a repeated factor, then you end up with more than one for each power of that repeated factor, more than one fraction in the final. And if you've got a quadratic factor, as we have here, then you get a quadratic factor, but with a linear expression on the top of it. So in summary, for the method, split the fraction into a sum of fractions, one for each of the factors in the original. Repeated factor, we know we form a fraction for each possible power. If you've got a quadratic factor, then you need to use a linear expression on the top for the numerator, something like ax plus b. And then the technique is the same as before. Multiply through by the denominator. Use selected values of x so that you get a 0 for bits of the expression. And then if there's anything left, you might need to look at the powers of x or the coefficients of the powers of x for any of the remaining constants. The next video in this sequence is 3.3, integrating with a denominator that has linear factors only.